so let's move on now to a discussion of the concept of mass percent composition. And we're going to talk about the definition of mass percent composition here. So the definition of mass percent composition of a compound is basically the number of grams of the particular element, each element that is present in a compound per 100 grams of the compound. So if you want to express this mathematically, whatever the percentage of the element is that is in the compound, we take that mass of the element divided by 100 grams of the particular compound. Or you simply take the mass of the element present in a sample of the compound divided by the mass of the compound times 100%. So these are two different ways of basically calculating the same thing, all right? And therefore, obviously, if you calculate the percentage by mass of each element in a compound, then when you add them up, you should get a total of 100%, all right? So for example, in the case of butane, the formula is given here, C4H10, right? How do we determine the percent composition of each element present in this compound? So what you'll do is start off by determining the molar mass of butane. So the molar mass of C4H10 would be equal to 4 times, for carbon, that's 12.01 grams per mole. And then to that, you add the total molar mass of hydrogen, which is 1.008 grams per mole, all right? And then we have to do the math or the arithmetic. So 4 times 12.01 equals that, plus 10 times 1.008. So according to my calculations, this works out to be equal to 58.12 grams per mole. And by the way, I could just as well use AMU for these units here, right? So if you use AMU instead of grams per mole, in which case you'll be calculating the molecular mass, same results, right? Okay, so the next step is to find the percentage of each element. So I'm going to start off with carbon. So the percentage of carbon would be the total molar mass of the carbons present according to the formula per mole. So that would be 4 times 12.01 grams per mole divided by the total molar mass of the entire compound, which is 58.12 grams per mole times 100%. So this will be equal to 48.04 grams per mole divided by 58.12 grams per mole times 100%. So let me do that calculation here. 48.04 divided by 58.12 and times 100%. And according to my calculations, when rounded off to 4 sig figs, that would be equal to 82.66. So the answer here is 82.66% because the grams per mole units will cancel out here and here. And we do basically the same thing for hydrogen, right? So in the case of hydrogen, that would be 10 times 1.008 grams per mole divided by, again, the total molar mass, 58.12 grams per mole, and then multiply by 100%. And so let me do that. 10 times 1.008 divided by 58.12 times 100%. And the answer I got is 17.34. So 17.34%. All right, so those are the percent composition values for carbon, which is 82.66%, and hydrogen, which is 17.34%. And as I said before, if you add up the total percentage, you should get 100, which is the case. If you add 82.66 plus 17.34, then the answer will be 100%. All right. Now, let me just say that very often, sometimes when you calculate the total percentage, it's not exactly 100%, but it should be relatively close. All right, so you might get something like 100.05% or something like that, which is, you know, close enough. All right. Okay, so that's basically how you determine the percentage of carbon and hydrogen in this compound known as butane. And pretty much this would be the same approach that you would take when it comes to determining the percentage composition of pretty much any compound if you know what the formula is. Okay, so let's look at these two examples and then we're going to stop this video here. So the first question is calculate the four significant figures, the mass percent of each element present in ammonium nitrate. All right. So what I'm going to do is get out of this and go to my writing application here. Let me get rid of this. Okay, so the first question says you have to calculate the formula, or I should say the mass percent of each element in ammonium nitrate, which means that we have to figure out what the formula for ammonium nitrate is. So again, this is something that you should know to do by now. You'd have to go to the chart and you'll see that the formula for ammonium is NH4 plus. The formula for nitrate is NO3 minus. So therefore that means that the formula for the compound formed between those two ions would be NH4NO3. All right. And then what you have to do now is find the molar mass of the entire compound. And that means you have to go to the periodic table and look up the molar masses of the different elements. Now, in this case, you have two nitrogen atoms here represented. So that's 2 times the molar mass of nitrogen, which is 14.01 grams per mole. And then to that, I would add 4 times the molar mass of hydrogen, which is 1.008 grams per mole. And then to that, I would add 3 times the molar mass of oxygen, which is 16.00 grams per mole. And then, again, we'll do the arithmetic. So 2 times 14.01 equals that, plus 4 times 1.008 equals that, plus 3 times 16 equals that. So according to my calculations, and in this case, I would have to round off to 2 decimal places. So this would be 80.05 grams per mole, all right? So to find the percentage of nitrogen, that would be equal to 2 times 14.01 grams per mole, 14.01, divided by 80.05 grams per mole times 100%. So let's see what that gives. So that is 28.02 divided by 80.05 times 100. So that will be equal to 35.00. Let me see here. 35.00%. And then in the case of the next element, which is hydrogen, that will be equal to 4 times 1.008 grams per mole divided by 80.05 grams per mole times 100%. Let's see what that gives. So 4 times 1.008 divided by 80.05. So according to my calculations, this works out to be equal to times 100. So according to my calculations, this works out to be equal to 5.037%. And then finally, in the case of oxygen, that will be equal to 3 times 16.00 grams per mole divided by 80.05 grams per mole times 100%. So that's 48.00 divided by 80.05 times 100. And in this case, the answer works out to be 59.96%. All right. And again, you can see if these answers are valid by adding all of these together, which should be equal to, if not 100%, very close to 100%. So let's do that. 35 plus 5 point, oops, let me do this again. 35 plus 5.037 plus 59.96. Okay, so the answer I got here is, well, when rounded off to 2 decimal places, the answer I got is 100.00%. So that tells us that at least the answers are valid, if not accurate. But I'm quite sure they're accurate. All right, so that's basically how this is done. All right, so that's the first example on that page. The second example is asking how many grams of nitrogen are present in 46.3 grams of ammonium nitrate. So same compound, ammonium nitrate, but this time we're given the mass of the compound, and the question is asking for the mass in grams of nitrogen present. So let me go back to this. Let me clean this up. So, oh shoot, I shouldn't have done that. I should have done that. I needed the percentage of nitrogen. In fact, I'm going to cheat a bit here. So what I'm going to do is, let me go to, I'm sorry about that, folks. I was too quick to remove that information that I worked out. So let me go to, okay, so the percentage of nitrogen was 35.00%. Okay, so that's based on the answer that we got before. So in this case here, the mass of ammonium nitrate given is 46.34 grams of NH4NO3. So basically, we need to find out the grams of nitrogen that is present. So since the percentage is 35.00% nitrogen present, then what we can do is set it up this way. 46.34 grams of NH4NO3. We multiply that by a conversion factor which represents the percentage of nitrogen present. And the way we would set this up is we would put up top here 35.00 grams of nitrogen, and down here we would put 100 grams of ammonium nitrate. Right? So that this will cancel out with this. So let's see what that gives. So that's 46.34 multiplied by 0.35. So the answer I got for the grams of nitrogen present is 16. Let me see how many sig figs. 4 sig figs. 16.22. So the answer here will be 16.22 grams of nitrogen that is present in this much ammonium nitrate. Okay, so that's basically how we do this particular example. So